Okay, hi and welcome. I'm going to be talking about transformations of functions. Okay, uh, what I'm going to do is I'm going to show you later on where I'll be taking everything from. I'm going to take you through a very nice journey through Pure Mathematics 1. Okay, so I'm going to take you through a journey through Pure Mathematics 1, every single thing. And the only way that you will know that you are done is if I'm going to be showing you what we are doing and explaining to you using the syllabus. So I'm going to be doing that for everything we are doing, and that's how it's going to go. Now, what I want you to know, transformations of functions, this is from Pure Mathematics 1. Okay? This is a Pure Mathematics 1 topic. We know that in Pure Mathematics 1, we have 8 topics. Okay? Pure Mathematics 1 has 8 topics. And here we are talking about one of the 8, which is the topic of functions. And we want to see how we transform them. This is something which can be tricky, but I'm going to show you the important things real quick, and you're going to see how to do it. Okay? So don't even fear it. It's just one of the things that you have to know. I'll explain every single thing in our live lessons every day. So we'll be consistent. Just make sure you're there every day. I will go live and we'll be doing these things for our Cambridge AS level, or at least once in 2 days. Now, here's the thing. We know that we did transformations at IGCSE level, and I don't need you to remember them. But what I want you to remember is that we have 4 transformations from IGCSE, right? For A level, you have 3 transformations to know. Okay? Right. We have here. Okay, Mpaso, hi. I can see you, Mpaso. Well done. For transformations, at IGCSE level, we were transforming shapes. So here I want to say transformations of functions. It could be also called transformations of graphs. Because what we will really be transforming is, yes, a function, but we know that every function has a graph. So we are going to be transforming graphs. At IGCSE, we transformed shapes, and we had enlargement where we made the shape either bigger or smaller, right? That was the first one. We had rotation where we flipped it, okay? Using a center, we'd find the center of rotation and stuff like that. Then we had reflection, and then we had translation. Translation was moving it, right? Okay? Translation, we were moving it in translation. Sorry for that. In translation, we were moving the shape. We didn't change anything to do with its size. We kept it as the same size, and we're moving it. Now, what I want you to know. So translation, we were just moving a shape. Take it from this position, put it to another. When we say we are doing a transformation, we are changing something about a shape. Something. When we are transforming, we are changing something. We could be changing the shape. We could be changing the size of the shape, okay? If we were doing with shapes, we could be changing the size of the shape. We could be changing its orientation. We could be changing its position. So if we change its orientation using a line, we call it reflection. We'll be using a line to change its orientation, like a mirror line, okay? Like a mirror. So we'll be using that line to flip it around. For rotation, we were flipping it using a point. And they'll tell you rotate it 90 degrees clockwise or something anti-clockwise. For enlargement, we'd be changing the size. We'd be making it bigger or smaller. That's still enlargement. Then for translation, we were changing its position. For translation, we were changing its position. Now what I want you to know is we are transforming functions, or we are transforming graphs. When we transform graphs, listen, it's a little more interesting. It's a little deeper. It's a little more interesting. First thing first. So we are not transforming shapes. You will not see a shape. You will see a graph. And that graph could be You would be having the function of the graph, or you could be having the graph itself, but you change something. Now we'll be doing three things. Either we will shift it. So translation now is called shift. Okay? We no longer call it translation. It used to be called translation. That means the graph would be moved, okay, from one position to another. What we used to call enlargement, here we are now calling stretch. Here we are now calling stretch. Okay, so enlargement is out. We now call it stretch. Then what used to be called reflection is still reflection. So there is no longer rotation. Okay, reflection is still reflection. What is no longer there is rotation. So we will reflect a graph, yes, or a function of the graph, yes. We will shift a graph, yes. We will stretch a graph, yes. We'll do all this to a graph, yes. So let's see how now. Let me just quickly show you, then I'm going to show you in examples and in written things. So at A level, remember I said it's becoming more interesting. It's no longer just basic, boring, 4 types of transformations where you either draw or you describe. That's the IGCSE version. Only 2 words. Either they'll ask you to draw or they'll ask you to describe, and it was just basic. In here, we now have much more. You are more grown up. So you got to remember, listen closely to how we're going to do it. What you must know is we are going to be changing a graph. We can either change it horizontally or we can change it vertically. Like if it's movement, you need to tell us, how are you moving it? It's a graph, right? It's not a shape. You don't just move it like that. For a graph, are you moving your points horizontally or are you moving them up and down? For stretch, are you stretching it up? Stretching it, make it long. You know, if it was like this, then you now make it like this. Everything is the same, but it's now just taller. You have stretched it vertically. Or you could make it like this. Let me show you where you stretch it horizontally. It's when the turning point does not change, but it's now just further. Okay? If you see here, the turning point here is still here. This one is still here. It's the same line. So vertically, we didn't move it. All we did was we shifted it horizontally. It moved like this. And this moved like this. This is a horizontal shift. You have moved the point. So we'll be moving special points. These turning points are the ones we are moving. Let's see how. So here's what I want you to know. There is horizontal transformation and there is vertical transformation. So for these 3, we are going to talk about them horizontally and we are going to talk about them vertically. So I want you to somewhere in between, right? We start with what? Horizontal? Okay, we can start with horizontal. Or should we start with vertical? It's fine. Or we can start with horizontal. We will start with horizontal. So each 3, there is we can have a shift, we can have a stretch, we can have a reflection. And the shift can be horizontal, the shift can be vertical. So here we are talking about a horizontal shift, then we talk about a horizontal stretch, talk about a horizontal reflection. So if it's a shift, what I want you to say here before, our original curve here, the original function right now that we have, is going to be y equal to f of x. This is the one we are transforming, okay? This is the one we are transforming. So which graph are we transforming? You need to know the graph that you are transforming. You are changing it. To transform means to change. You can't transform from nothing. You have to change something. So the one we're changing is f of x. So if it's a shift, how do you see a shift? Your graph will have a new number adding. Something new will add. So for shift, you add or subtract a constant. Okay? Go step by step with me. You understand more when we are looking at examples. Don't fly to the top of the bridge. Go all the way to the top. Don't fly. We'll get there. So we know that for a shift, where we move points. Shift, you move the points. You just move it. When we are going to shift or move a point, you would have added or subtracted a value. Now, if it's a horizontal shift, horizontal, I want you to know two things about horizontal. Number one, they happen right where X is, right inside the function. They happen right where X is. That is where a horizontal transformation will take place. A horizontal transformation, listen, it happens inside the function. That's the first thing. Put these points and you understand. The second thing is that it always lies. It always lies. Okay? Number one, they happen right inside, then they always lie. So let's see here. If you have f of, or you can now have, instead of y being f of x, you now have y is equal to f of x plus a. Y is equal to f of x plus a. Remember, the original one was y is f of x. Now we will see, I'll show you in examples, okay? You will see now an a adding. You now have an f of x plus a. We are adding now. We have added. So obviously, this is a what? This is a shift. This graph has been shifted. We are adding. And look, class, we are adding inside. Inside. Right where X is. Give me a second. So, look, sorry for the small glitch, eh? I'm back. What I wanted you to see, listen closely. When it's a shift, we will add. Now, remember, you are more grown up now. Yes, a shift will add, but there are two types. So you can add in two ways. Number one, you have to know that to add or to subtract is a shift. Then number two, you have to know that if it's horizontal, you are adding inside, right next to X. So if you had, for example, let me say, when this happens, so let's put an example, leave some space, okay, leave some space. E.g., if you have y is equal to x squared minus 9x plus 2. If you now have a new function, if you now have a new function which says y is equal to x plus 3 squared minus 9 of x plus 3 plus 2. Look at this. What you can see is that where there was x, we now have an x plus 3. Where there was x, we now have an x plus 3. Where there was x here, we now have an x plus 3. So because it's changing the x, it has to be horizontal. Horizontal will attack every single x value because it changes from the inside. So if it's multiplying, it will multiply wherever there is x. If there was an x, you now start to see a 2x, a 2x, a 2x. That means it has changed. If it is dividing, you see an x over 2, x over 2 on every single x. That means every single x is changing. That's a horizontal something. So all these horizontal things will change our x. You should look at how the x has changed. If it's an addition, then it is a shift. If it's an addition, I'll show you the vertical ones. If it's an addition, then it's a shift. Now remember that when you are describing it, shift is a liar. You see it say x plus 3, so you think it's shifting to the right by 3. Because usually we know that when you add, you shift to the right. But not on horizontal. Horizontal is now a liar. So that means when it says x plus a, you now actually say it is shift by a units to the left. To the left. You say, what? But we added. So you get a mark for knowing it's a shift. You know it's a shift. So well done to you. And it's shifted by a units. Well done to you. But now you must know that it's to the left when it's a plus. If it's a minus, it would be to the right. So for here, it's shift by a units to the right. If we now have y equal to f of x minus a, this becomes shift by a units to the right. So the first thing, it's a shift, yes. And I want you to say, you don't just say a shift, by the way. Let's even add. That's not even correct. You should say horizontal shift. Horizontal shift, okay? Horizontal shift. I know that saying to the right or to the left tells you it's horizontal, but say it. Say horizontal shift by a units to the right. Here, horizontal shift, because we are adding right or subtracting right inside. When it's a subtraction, we move to the right. Yes, watch out. This is going to be true for all transformations when they are horizontal. It's a liar. When you see it multiply, you think, hey, the scale factor is not what you are seeing. It's the opposite. Be careful. Horizontal is a liar, guys. Horizontal shift, watch out for him. Horizontal, we now know you. You are not going to get us, man. All right, so let's talk about stretch. For stretch, this is when you multiply or divide the original function. So you should look for the original function. Then you see, oh, when you multiply or divide, when you multiply or divide by a constant, then now it becomes a stretch. If you multiply or divide by a constant, then now it's a stretch. Stretch multiplies or divides. Don't forget. So our original graph was y equal to f of x. The new one, we are dividing or multiplying, and because we want it to be horizontal, we will do that inside. We will divide or multiply inside. Remember now, the thing is so big. Every transformation, you should know what it does. Then you should know what it does horizontally and then vertically. So you know stretch will multiply or divide. Now for horizontally, it will multiply or divide inside the function. So you'll be now having y being equal to f of x over a. This is an example. Or y is, you can have it say y is equal to f of ax. So it's no longer an x. Every x will now be like a 3x or a 5x, 9x, whatever. That shows you have multiplied. So you are stretching the graph. We'll see how we stretch. But first you must know what we are doing. We'll see how we stretch, okay? We'll get there. So let's see here. Y is f of x over a. What is this? I want you to say horizontal stretch. For example, let's say your original was, e.g., let's say original was y equal to x squared plus 5x minus 9. Let's say you now have the new one. New one is y is equal to x over 3 o squared plus 5 by x over 3 minus 9. Okay, they can go ahead and go and simplify it. But what you see is every single place where there was x will change. And it is being divided by a constant on every single position where there was x. Oh, that's a stretch. And that's a horizontal stretch. The fact that it's dividing makes it a stretch. The fact that it's dividing inside makes it a horizontal stretch. It was a stretch because it was a division. Because it was dividing everywhere where there is x, it now makes it horizontal. So this is now a horizontal stretch. So you know it's a horizontal stretch. When you are describing it, be careful, it's lying to you. So once you see it's a horizontal stretch, now let's see how we will describe it. So let's see how we will describe. We will describe knowing we are describing horizontal. So here you say this is a horizontal stretch. This is a horizontal stretch. Well done. And you now say by scale factor. By scale factor. You thought the scale factor would be 1/3 because it's dividing. So if it was dividing, the scale factor is supposed to be 1/3. But horizontal is a liar. So you will say by scale factor 3. Change what it's saying. So it will be by scale factor 3. For here, we'll see more examples. But for here, you will be now saying this becomes a horizontal stretch. This becomes a horizontal stretch by scale factor. By scale factor, you now say 1/a. Okay. If every x is now a 5x, 5x squared, 5x 9, 5x what, every x is now a 5x. That means you have multiplied every x. You've done a horizontal transformation. When you are now describing, say 1/1 on your scale factor. Don't let me down. I've told you and told you and told you. Don't let me down. Anyway, I'm going to end here. I don't want to keep going. I'll be continuing, okay? This is a series, and it'll be nice and short and powerful. So I'm going to go again live later for P3, A2 mathematics. But here, I want you to see these. I'm going to give you examples. We are finishing the last transformation tomorrow, and then we are going to do several examples together, and then we are going to see. I know, right? Make sure you have subscribed. You turn on the notification. Whenever I go live, you need to make sure you see it. Right. Thank you, Mpaso. Thank you, everybody. This is going to be it. I'm going to go. Keep this, rewatch it, and rewatch it again before I continue tomorrow. Make sure you hear every single thing. So the stretch multiplies horizontal. It will be inside and stuff like that. Goodbye.